appreciate the audience. Still, it is lazy Sunday afternoon and still you are there and I can see anxious faces outside of your colleagues. So I won't take much of your time. I will finish it off as early as possible. Initially, actually the topic is implementation of FGD in coal-based Indian thermal power plants. Now my question is why such topic is required at all? So it's solution of some problem. So what is the problem? I will try to show it. So the problem is that FGD implementation is required for pollution control. So one problem is that I have to keep my climate very clean. Second is that I have to generate power for future generation or for current development. So problem is basically twofold. One is generation of electricity, and second is to intact the environment clean. And third is that we must keep in mind that for future generation also, we must keep some reserve capacity so that they should not curse us that we have finished everything. So that way, let's start. Okay, so I thought it is a threefold. So second fold now I can skip because it's a lot has been talked. So let's see present energy scenario. So this is a night vision. And we must be proud that India in a night, it is showing very illuminated. So it's basically this picture reflects which country produces how much of energy. And we must take pride that India is quite a big leader in that. But again, picture doesn't tell all. If we divide by number of population, means if we average it by per capita energy consumption, then we will see what happens. So before that, let's move ahead. How this requirement increases gradually over time. First, in the primitive time, the only energy is required for food consumption, air transport, and movement, etc. With gradually industrialization, the energy requirement is increasing day by day. So if we want to sustain the economic growth of 8 to 9% per year, we must continuously supply the energy. Okay, so this is a very interesting graph. You can follow it. Basically, if you want to take only one message, you can take this one. This is per capita electricity consumptions. I mean, basically, how much electricity you produce divided by number of people versus human development index. So human development is dependent on so many things, how much food is available, how much education, health, blah, blah, but ultimately all this development depends on energy production. So if you draw this curve, so it is something like that. So it's gradually increasing, and after 0.9, it is becoming asymptotic. So where are we as a country? We are here at 0.6. So we may be very happy that at least Pakistan is behind us. But this doesn't tell the correct picture. Actually, you see Canada, United States, Australia, and even Norway, all are very far away. But interesting thing is that, say we are here. Now, if we aim at here, it is like my daughter scoring 30 marks in mathematics and I'm expecting 200. It is not so. So I can, it's a very feasible target is somewhere 0.8 or something like this. This is the midpoint of the knee. Means after that, if we increase the power, there is not much change in human HDI. So 0.6 to 0.8 jump means if we come to the x-axis, it comes around 2,000 kilowatt per person per year. So our target is as a nation is 2,000 kilowatt per person. So you multiply with person, you'll come to know what is our requirement. Now this is our requirement. Like my family tells, I need 50,000 rupees per month or whatever. But how much can I afford? Let's see. Okay. So in a global scenario, again, this data is little updated, but not very much, trend is not changing. World average is 2,752. Forget about USA or Japan. We are far below in the world standard. India is 704. This is per capita. I told you now, the picture, when you divide with the number of people, it is different. So we are almost 1/3 of the world average. And the average consists of countries like Africa where there is no electricity at all. So you can understand how much emphasis we have to give a jump to here to there. Okay, next. So as I told you, if you consider the economic growth of 8 to 9%, population growth, etc., so the energy requirement, bottom line is that by 2050, our requirement is roughly 5,000 kilowatt hour. So this should be our target. We can't think of only 4 or 5 years, we have to think future ahead. Now, what is the present scenario again? This is again 1 year back data, 2018 March. As expected, that thermal is the king. They hold the lion's share. So it is 64.8%, maybe a little bit changed by 1 year. and hydro is this much, renewable and nuclear. So nuclear is only 2% of the total supply, and 64.8% comes from thermal. So since you are contributing much to the demand, your responsibility to the environment is also much more. This is, again, I'm trying to see in near future, our reserve capacity of energy resources. The coal, at Bhattacharya said, told in early morning, it will survive for another 100 years. So by coming 100 years, thermal power plant, they will have a major role to play. But after that, you have to think of something. Or maybe from right now, we can mix different energy options, like a nuclear reactor, hydro, gas, oil, and of course, solar. So you have only two options, renewable energy, and okay, I can go back to one slide. I can tell one sentence about this. This is an information that uranium-235 is a fissionable material. You can directly produce energy by fission of it. But India, again, have very little amount of uranium. So we have to be dependent on our neighboring countries, or Europe or USA countries. So, but India has a lot of thorium, especially in Kerala, in the sand beach. And this thorium, again, with some processing, can be converted into fissile material. And if this technology works, we can say we are half done. So if it works, it can take care of around 500 years of coming. Okay. So next is we have options. We have to take advantage of everything, biomass, starting from biomass, solar, hydropower, etc. But say for solar, it is a intermittent source of energy. It's something like mood of my wife, kabhi khushi, kabhi gum. Means you won't get a service from every time. Okay. But this other side, say nuclear or fossil, it's like parents. You will get constant support from them. So accordingly, you have to choose very wisely which options can be used. And nowadays, people are very conscious. They are mixing all the energy options. Okay, this is a direct comparison. You can skip it. So in the secondary side, nuclear and thermal, it is same, absolutely same. Only in the primary part, in the heat source part, this boiler, this coal thing has been replaced by a fission reaction. So the reaction is happening here, is carbon plus oxygen equal to carbon dioxide plus 4 eV. And if you think of fission, it is coming around 200 MeV, right? And here you are getting some carbon dioxide. Here it is not carbon dioxide, but it has its own issue, like radioactive waste, etc. So let's try to simple math of class 9-10. I have tried, you can check. Say we want to establish a power plant of 1 megawatt day electrical. So 1 megawatt day electrical is converted to this much of joule. Now come to the first equation, carbon plus oxygen, it is 4 electron volt. So mass of one carbon atom is this much. Atomic weight divided by Avogadro number. So this much gram produces this much joule energy. And similarly, you can find the amount. It will require 3 tons of carbon. And if you want to produce the same energy by using a nuclear fission reactor, it is coming around 1 gram. I'm not advocating for nuclear or thermal. What I'm saying is all these options has to be used. Now, present scenario, you can see in India, fossil fuel again is major part. In almost all the countries, the problem is not our only problem, its problem is across the world. Why it's not moving? Here I am. Okay. Sorry. So anyway, yeah, here we are. So vis-a-vis a comparison between coal-fired plant and a nuclear power plant, it is not much required, but the point to highlight is that emission of carbon dioxide, sulfur dioxide, and NOx, this has to be emitted, and that is why today we are here. So if we give a graph of our requirement versus how much we can produce, you can say this coal part is by blue color, and there is definitely a gap, what is required and what we can provide. So this deficiency has to be met by a combination of nuclear, coal, as well as all the energy options like solar and biomass, etc. Now, FDG part, it has been covered, but for the sake of completeness, I can take 1 minute. This was very recent pictures, not very 1 year before picture. This is Bangladesh team when they came to Delhi. This is the air quality. And this picture even is more recent. It is from Australia, just 3 days back. So science is clear, the air is not. And so we are here for that reason. So its problem is everywhere. How SOx is very harmful, you already come to know. There is not much to say. But the research, the survey says out of top 10 SO2 emission hotspot, 5 is from India. So we cannot deny our responsibility. We have to take this issue. And another news article, it says 71% increment of SOx emission within last 5 years. And the Supreme Court already ordered that by 2022, which seems to be very difficult, all these things have to be taken care of. These things has already been discussed. Now, okay. Again, already NTPC, some plants, they have implemented these things, and this is a very comprehensive comparison that limestone-based system, there will be a carbon dioxide emission. The Bhattacharya sir, in the very first lecture, he told this is a paradox. I want to eliminate the SOx, but in turns I'm generating carbon dioxide. So likewise, all the methods have their own merits and demerits, and I am also interested to listen in the panel discussion what is the expert's opinion in Indian context, what could be used and what could be useful. And finally, this is probably my last slide. What is the significance? Significance is that if you want to run a family, and say if you say that your demand is increasing day by day, you can increase your earning. But other side is that you can stop, means you can decrease the energy expenditure. So similarly, if you take a candle, standard candle, if you illuminate it, you will have some light as well as some heat. So interestingly, the Jonaki poka or the fireflies, if you take a ratio of illumination divided by the total energy is converted into light energy, illumination. But for candle, it is much more heat energy. So our earlier bulbs, their efficiency has to be less than 1%, even maybe 4%. But inspired by this natural phenomena, LED bulb has come in picture, and that efficiency has increased. And you'll be surprised to know, first of all, we must thank that person who has invented it. He didn't file any patent for it. And as he didn't patent this file for it, India could save huge amount of money implementing this LED thing. And I forgot the value, but it is exactly equal to the higher education budget for India. So for 1 year, higher education budget came from directly implementing LED. Still, it is not matching the efficiency of this firefly. So we have still some path to go. I hope in future, with innovation of scientists or etc., we can mimic the nature and our energy consumption can be reduced. So these are all 3 approaches I can share with you with which we can take care of future. Thank you all for your patience hearing. Okay, just I would add few comments. So my daughter only asked, LED light, you are implementing in your homes, it's a very hazardous. So I tried to survey literature, what's the harm in it? So the only hazard I found is that this is a night picture of India. This is night, this is not day. So basically we are doing light pollution. If anything is given to human being very easily, they will misuse it. So there is a quote, na, hum nahi sudrega. So first thing we have to correct ourselves, then everything will happen. So this is my final message. Thank you again.